Dear students, today we will discuss Couette flow. So let's start. So today we discuss about the Couette flow, which is the special condition of a laminar fluid flow between two parallel plates. So here lower plate is fixed and upper plate is moving in the direction of the flow. This is your flow direction of the flow with a uniform velocity capital U. This distance is suppose h. So governing equation for laminar flow between two parallel plates is given by this: mu d square u dy square is equal to dp by dx. So from this equation, if we integrate by integrating twice with respect to y, we get du by dy is equal to 1 by mu dp dx y c. Again we integrate, you will get u is equal to dp dx y is squared plus c1y plus c2. So here if we apply boundary condition, so at y is equal to 0, u is equal to 0. So this is your parallel plate, this one moving in a direction u, this one is fixed, this direction is y, this direction is x. So at y is equal to 0, your velocity will be 0 because it is fixed. And at y is equal to s, because this distance is capital S, your small y is equal to capital U. This is the uniform velocity of this plate which is moving in the direction of the flow. So if I put the value in this equation, from this equation suppose it is 1, so from 1 we get C2 is equal to 0 and C1 is equal to capital U H minus half mu dp dx capital S. Now if you put the value of C1, C2 in equation 1, so from equation 1 we get u is equal to 1 by 2 mu dp dx y square minus y h plus capital U h y. So this is the governing equation of the Couette flow. If upper plate is moving in the direction of the flow with a uniform velocity capital U. So if you observe the equation, this equation is parabolic in nature. So it will be like this. This is your upper plate, this is your fixed plate, this is your fixed plate. And if you draw the velocity profile, it will be like this. The velocity profile will be like this. If dp by dx is not equal to 0, if dp by dx, that is this one is moving with a velocity capital U, this upper plate is moving with a velocity capital U. So for dp by dx is equal to 0, when this became 0, this whole portion became 0. So in this scenario, u will be equal to capital U h by y, so which is linear in nature. So this will be the velocity, this will be the velocity, this is linear in nature when pressure gradient is 0. This is called pure Couette flow. Now if you consider another scenario, suppose scenario is like this. This upper plate is fixed and lower plate is moving with a uniform velocity capital U in the opposite direction of the flow. This is your flow of the fluid and it is moving opposite direction. Then what will be the governing equation? As you know, the governing equation for fluid flow between two parallel plates is given by mu del E square U dy square dp dx. So again we integrate by integrating twice with respect to y, we get du dy is equal to 1 by mu dp dx y plus c1. Again u will be half mu dp dx, this will be y square plus c1y plus c2. Now if you apply boundary condition for this scenario is like this. The upper plate is fixed, lower plate is moving in this direction. This is your fluid flow. So applying boundary condition, so at this is your y, this is your x. So at y is equal to h, your small u is equal to, so at here it will be 0, and at y is equal to 0, your small u is minus capital U. Why it is minus? Because your fluid is flowing in from left to right, but this plate is moving from the right to left. So if I put the value of those in this equation number 1, or you can say equation number 2, we will get C2 is equal to minus capital U and C1 is equal to capital U H divided by H minus half mu dp dx h. So if I put the value of C1 and C2 in the equation 2, we will get, in the equation 2, you will get small u is equal to half mu dp dx y square yh. That is capital U y by h minus 1. So this is the governing equation for this type of Couette flow. Thank you. Hope you understand. Now I give you one assignment to you. Try to solve one problem. Suppose these two parallel plates, distance between these two parallel plates is capital H, and fluid is flowing from this direction, from left to right. An upper plate is moving in the direction of the fluid with a uniform velocity capital U, and lower plate is moving in opposite direction with a same uniform velocity capital U. Under this condition, what will be the velocity? Let's try to solve this problem yourself. Thank you.